A battery of 384 volts is connected in series to two resistors in series, each with 96 ohms. How much power is dissipated in one of the resistors? So we have a battery with 384 volts connected in series to two resistors and each with 96 ohms. So before we calculate anything, we could analyze the formula for power dissipated by resistors, and that is I squared times R. And so because the resistances for either of the resistors are the same, we should expect that the power dissipated by either one would be equal to the other. So in order to solve for power, we need to solve for I, the current. And the current is given by V over R. So if we solve for the current throughout this circuit, we could plug this in and solve for the power dissipated by one of the resistor. So first we need to find the equivalent resistance in this circuit. So R equivalent for series is equal to R1 plus R2 and so on. And in this case we only have two resistors. So the equivalent resistance would be 96 ohms plus 96 ohms. And that should give us 2 times 96 ohms, which is 192 ohms. So now we have the equivalent resistance of this circuit. We could solve for the current, and the current is given by V over R, and the battery has 384 volts. Around a circuit of 192 ohms. So this should give us 2 amps. So now that we have the current in the system, we could solve for power, which is given by I squared times R. And in our case, we need to find the power dissipated by one of the resistor, and so we use 96 ohms instead of the equivalent resistance, 192 ohms. So the power is given by 2 amps squared times the resistance, which is 96 ohms. So that gives us 4 amps squared times 96 ohms. And 4 times 96 is 384, and amp squared times ohms gives us watts. So the power dissipated by one of the resistor is 384 watts.